professor at City Tech, one of the CUNY campuses in downtown Brooklyn, and he is my co-director for the CUNY OER WeBWorK Fellows Project. And he has been working with WeBWorK for many years now. He's our WeBWorK guru. So we're thrilled to have him here, and he's going to talk to us about basic problem authoring. So thank you, Drew.
Thanks, Mariana. So I'm going to throw, well, actually, I just lost my chat window. I was going to throw up there it is. There's a link here. I've posted my slides to a GitHub repository for this talk. There are also some problem templates in there, and you can follow along with the materials there, or you can look through them afterwards. So let's hop right into it. So this is an introduction to authoring problems in WeBWorK. I'm going to start by looking at a little bit of the fundamentals of Perl. Now, I'm not trying to scare anybody, but there are definitely some basics about coding and some specific things about coding in Perl that are relevant to working with the WeBWorK problem authoring interface. So, you know, programming with Perl, you know, it's got a little bit of reputation, but let's just hop into some of the basics. So when you define variables in Perl, you're going to make sure that those are preceded with a $sign, right? So anything that you name with a leading $sign, that's going to be a variable. You can store stuff in there like here I've set tau equal to 2 times pi, or you can, you know, store strings, which is just text. You can just put text into a variable as well. Any line of executable code, you need to end with a semicolon. Along, you know, as with most programming languages, there are conditional statements. You can use if. If you want to use things like else if, it's slightly different in Perl than what you might be used to. Don't finish spelling the word else, and there's no space. ELSIF is what you'll use for else if. You can define other data structures like arrays and hashes, but you're going to define those as I've indicated down here. Use some parentheses. It's going to make your life a lot easier when you define things as lists. Just remember that for things like arrays, indices always start at 0. So your first object is indexed as in the 0 position. Commenting in Perl, commenting your code is always welcome. You're going to use the # to indicate that whatever follows the # is comment. So it won't be processed as code. And I've got a link in here for any of you who want to learn a lot more about Perl. This is a very deep hole, but you can learn Perl in about 2.5 hours reading this document. I found it very, very helpful when I was just starting out. All right, so let's hop into problem structure in PG. PG is the language that we use for coding up problems in WeBWorK. So there's been a lot of development. PG has evolved quite a bit over the past 25 years. You know, I myself got my start by editing problems from the Open Problem Library. I know a lot of you who have experience coding problems probably started the same way. One thing that I will throw out there as a caveat is that the OPL problems are getting older. A lot of the strategies for coding problems have evolved and changed, and there are different best practices now. However, the metadata and the tagging for problems that are in the OPL, that's timeless. So if you want to know how you should be tagging your problems, look no farther than the OPL and use those as your inspiration for how you tag your problems. Just be aware, the OPL does span several generations of how we've authored problems, and so it can be somewhat confusing as you flip through OPL problems. The strategies that they use aren't always consistent, and it can be somewhat confusing. So I'm going to present what I think is best practices for coding in PG in the modern frameworks. There have been two major leaps forward in PG development. One of them is math objects. So instead of just defining variables to be something that has a value, we now have math objects. They not only have a value, but they also know things about themselves. They can represent themselves in different formats. Plain text, they can text themselves, put themselves into LaTeX form. They know how they should be compared to other objects, like especially when a student submits an answer, how do we compare? What is equivalence between what I think is the answer as the problem author and what the student thinks is the answer? And the second major leap forward is using PGML, which is a PG markup language, which allows us to format the problem text in a uniform and relatively easy to use manner. So what should your problem look like structurally? Well, one, you're going to want to make sure that your problem includes metadata. This is really important. I know it can be very tempting to say, like, I'm just going to use my problems at my institution. It works good enough for us. I don't necessarily want to share my content, but the community really benefits from everyone contributing their content and sharing it with each other. Now, the thing is sharing your content means that you need to make it easy to find. Just putting your problems out there only goes so far. I need to be able to look in the problem library and do some searching and find your content. If it's not tagged, I'm going to have a really hard time finding your problem. Your problem might be fantastic, but if I can't find it, I'll never really be able to see how awesome your content is. Then you're going to continue with the setup of your problem. Here you'll build the parameters that you're going to use to ask the question that you want to ask. So here's where most of the coding comes in. You're going to hopefully randomize your problems, this generates the parameters that you'll use to ask your question. And finally, the display. So you're going to ask the problem, format your question, maybe use LaTeX. You might provide hints and solutions, but this is all the text that appears on the problem page when the student views it. Okay, so how do we set this all up? I can't say this enough, but starting with the tags is probably your best bet. I know I'm saying this in hindsight. I didn't always do the best job of this, and I allowed a lot of problems that I authored to pile up without being tagged, and then it becomes a really huge pain to go back, and then it's just tag problem after problem after problem, and it's a lot of repetitive, redundant work. If you handle this at the beginning, especially if you pick a particular topic to work on, then the tags will be consistent, and you can just use the same block of tags, relatively speaking, when you start coding the problem, and then you don't have to go back and do it again. So subject, chapter, and section. I believe there's a link in the intro markdown file that's on my GitHub that I linked in the chat. That'll take you to the list of all the different WeBWorK library subjects, chapters, and sections. You can also find all the keywords there. And don't forget to give yourself credit. There's an author field, and you can make sure that you specify that you're the one who wrote this problem. Okay, so the first part of setting up the framework for your problem is to choose the right context. And context determines the settings for the objects that you create. So very commonly we use the numeric context. Numeric context handles real numbers, it handles formulas, which a lot of times is all that you might need. You can configure the different variables that you want to use. If you want your functions to use t instead of x, or you want to use a multi-dimensional function, so you can have x, y, and z as your variables for your formulas. You can do that all through the context. The context controls the settings for the objects that you create. If you want to create points, same thing. You can change the dimension of your space by adding additional variables to the context. If you want to work with complex numbers, you need to set the context for that. Including the imaginary number is not something that's included in the numeric context by default. You need to switch over and use complex. Vectors, matrices, again, allow you, in vector form, you can use different styles of notation, and that's all controlled through the context. Matrices allow you to create matrix objects that inherently support their own computation for determinants, transposes, inverses, and trace. And finally, intervals. If you want to work with intervals, this supports, taking unions or intersections. You can tell whether or not intervals are subsets of each other. It supports reduction. If you define an interval that happens to be the union of two overlapping sets, it supports reducing that. It also supports finite sets of real numbers. If you want to get fancy, there are a lot of other contexts that are not supported by default. You need to use, you see here the mention of the load macros call. It's kind of like if you've ever worked with LaTeX. You can import other libraries to enable extra features. And the same is true in WeBWorK. So if you want other contexts, they're available. There's a lot of them. And you can choose, but you just need to make sure that you load the corresponding macro at the beginning of the file. All contexts have configurable parameters, so maybe you don't need an entirely new context. You just need to manipulate the one that works for you. So all the contexts have configurable settings, and you can find information about those settings. Again, if you look at the intro markdown file in the GitHub repository that I shared in the chat. Finally, you can customize context by writing your own answer checker or using other add-ons like answer hints that allow you to recognize common incorrect answers and provide students with specialized feedback when they make those common mistakes. There's a lot of customization you can do. This is a very, very deep hole, and we're going to kind of stick to the surface for the purposes of this talk. So one of the big features with WeBWorK is making sure that you can randomize your questions. So there are a few different ways of handling randomization in WeBWorK. The most common is just random. There's a function called random. You specify your minimum number, your maximum number, and there's an optional step that you can provide. It allows you to say, I would like to select a random number between the minimum and the maximum at intervals of whatever step you choose. That step defaults to 1, so it's very easy to use the random function to generate random integers. You can also use a list random call where you list the options that you want to choose from, and list random randomly selects one of those options. And finally, you can use, if you're more familiar with programming and you know how to use a do-while loop, you can use one of those loops to enforce restrictions on your randomization. You can, inside the do loop, you can generate random numbers, and you do it until you satisfy certain conditions. And then, you can be sure that your randomization is controlled. And that's important because randomization can really get out of hand quickly. If you're not careful, you can end up with solutions that are exorbitantly large, or vice versa, incredibly minuscule, and you might not want to do that. That you're not necessarily providing a consistent difficulty level across all randomizations. So if you think about what you want your solutions to be before you start writing the problem, you can enforce restrictions on your randomization, and it will make sure that the random problems that you create are more consistent from randomization to randomization. Okay, so in putting it all together, you're going to want to use the random parameters that you generated and use them to construct new math objects. Here we see $F, that's a variable, right? So I'm defining a new variable called f, and I'm defining it to be a specific object. I want it to be a formula. Now, math objects are always begin with a capital letter. So this formula, it's the square root of x squared minus c squared. So let's say I generated a random parameter c, and this will generate a formula from that parameter. Then you want to make sure that you're also generating math objects for your answers as well. So here, let's say I want to ask about my function. I want to ask, what's the domain of this function? So here I have generated another variable, $ans, as my answer object. It's defined to be an interval. Again, starting with the capital letter, we know that this is a math object. And that math object is capital R, the real numbers, set minus the interval from -c to c. And then you see that both of these use the, and what looks to be like an arrow and a reduce. This is a method on the math object itself. These math objects know how to reduce themselves. So any formulas that you plan on displaying to students, you're going to want to oftentimes use reduce. It will make sure that the formula looks the way you want. It simplifies things. For instance, if you had a formula that was a random parameter times x, if that random parameter ends up being 1, then it looks like your formula will be written as 1x. And you know that we don't normally display 1x. We would rather just say x, right? So reduce is going to take care of a lot of these common situations that arise when you randomize parameters. Same goes for answers as well. You're going to want to make sure that the answers are reduced. All right, so after you've done some randomization, you've constructed your math objects and your answers, you're going to want to lay out the actual problem. Now, this is where PGML comes in. PGML blocks don't work as code. When you are in between a begin PGML and end PGML, you don't want to be doing any more code execution. So everything between begin and end PGML should be treated as display. This is text to be displayed to your students for this problem. So there's also begin and end PGML hints and solutions. So these are important things to add to your problem so that students might get a little bit of a hint, or definitely solutions after the solution date has passed. Okay, so in Markdown language, if you're familiar with Markdown from GitHub or Wikipedia or any number of other places that use Markdown language, there's some very common things that are consistent with PGML as well. Putting asterisks around text, make it bold. Underscores around text, make it italic. And you can do numbered lists by just starting with one period and a space. So by hitting new line after, you could hit one period and then put your second item, and PGML will recognize and automatically increment your numbered list automatically. You can use variables in your PGML as well. The thing is that if you just wrote $variable inside a PGML block, it would just print it out exactly as you wrote it, $variable. By wrapping your variables in square brackets, PGML knows that you mean for this to be treated as a variable, and it will instead substitute the value of the variable in place of writing out $variable instead. And then you can also use tech in your PGML blocks. You can see here that I've got 3 very similar looking pieces of code. The only difference is the number of tick marks. These are not single quotes, these are tick marks. It's the key that shares the tilde on your keyboard. By using an increasing number of ticks, you can change the style of text that is used to render what's inside. So single ticks is just math mode. Double ticks is inline still, but uses display style. And 3 ticks is your usual not inline display style where your LaTeX is centered and there's additional padding above and below the math. That's when it's rendered. Okay, so let's write some code. I'm going to, oops, let me swap over. Okay, so here I have, I've pulled up my GitHub repository. If you want to take a look, I've uploaded some things to support today's talk. There's more here than what I'm going to be able to get through in my remaining, I think I have another half an hour. So if you take a look at the intro markdown file, you'll see I roughly followed the same outline as the talk today, but there's a whole lot of extra information. The link to learning Perl is here. There's a lot more discussion about Perl. There's a lot of links to the WeBWorK wiki that provide additional support documentation for using math objects and contexts and the various settings that you can change in a context or for an individual math object itself. So I highly recommend taking a look at this after today's talk. But most of what we'll be working on are the problems that I've put in the templates directory. So if you follow along with today's talk and then you want to be reminded of the things that we went over, there's a lot of different evolutions of a problem, and we're going to go through that now. So I want to start with just a bare bones problem, just to kind of go over what, am I actually sharing the, okay. Make sure I'm sharing the right thing here. I want to go over the structure of a WeBWorK problem. So we start here with document. Again, if you're familiar with LaTeX, you know, this is familiar. You just start with the document call. Here we see the load macros that I mentioned before. I've only got 2 macros that I want to load in. PG standard, that loads up all my contexts like numeric, point, vector, matrix. None of the specialized ones, but it's good enough for most problems. And I want to load in PGML because that's what I want to use to lay out my problem text. A begin problem call is also required. And then we get into the actual writing of the problem. So here I've set a context of numeric, and I'm defining some variables. I don't really need to do this. I just want to use it as an example. I'm going to put my instructions in a variable just to show, hey, you know what? I can put text into a variable. I can put raw LaTeX into a variable as well. The only thing that's truly necessary in a WeBWorK problem is for you to define an answer object. So that's all I've done for the setup of my problem. And you can see here I have my block of begin PGML and end PGML. I've got my instructions. Again, if I were to leave off the brackets around my instructions, then what's rendered in PGML is just literally $instructions instead of the contents of a variable. So we want to make sure that we put some square brackets around that, and PGML recognizes that now as a variable and instead substitutes the value, evaluate the following text into that variable in its place. Below I have my LaTeX block. If I add another set of tick marks around this, I should get display mode or display style. And as you can see, my LaTeX is now centered and a little bit more padded. If I were to do it with just a single pair, I get the inline. It's not quite as spaced out. I personally lean towards inline display mode a lot.
Andrew, it's
yes.
hard to see your screen. Can you make the program screen bigger? Ah.
Is that better?
I think so, yes, thank you.
Thanks, Karen. Okay, so in the PGML block, I've got things that I'm displaying to the students. Again, I don't need to do this you know, variable substitution. I can just put text in here instead. And the same is true with the problem text. I don't actually have to put this in a variable. I can just put it directly into, my text block. And it doesn't change anything. When I click render, I still see the exact same thing. Now, as far as an answer goes, you'll notice that there's some blue text here. And this is, you're going to get used to this very quickly because this is how you ask students to respond. An answer blank is square brackets with any number of underscores in between. You don't really need to make this long. You just need one. I think just one should work. Yep, and my answer blank is still there. And if you look after the answer blank, I've got some curly braces. And inside the curly braces, I have specified the answer object for this question blank. How should students respond? What is the correct answer? So in the correct answer, I've got pi. So when I submit my answers, hey, that's correct, right? No surprise there. Again, if I wanted to get, you know, there's nothing stopping me from submitting any number of different things that are equivalent to pi as well. Okay, so let's think about how we might build up this problem, because this is a very boring problem. This is a static, I would call this a static problem. There's no calls to randomize here. The problem is the same for everyone. If I attempt to change, for in WeBWorK parlance, the random seed, the number that determines which version of the randomization I get, if I change this and I re-render it, I get exactly the same problem because there's no randomization here.
Andrew.
Yes.
In the real parentheses, quote unquote pi,
yes.
Is it, if a student put pi like pi, would that take also?
Yes. In fact, you see here that I'm going to try to type pi, but as soon as I type the letter I, MathQuill recognizes that as pi.
Oh, beautiful. That's
yeah.
Beautiful. Yeah, beautiful. Thank you.
And I think based on tolerance, all right, you know, I can give an estimate and still be counted correct. These are things that are adjustable within the context. I can change the tolerance of what should be accepted as being close enough to pi. Okay, so let's try to work in some randomization. What could we randomize here? Well, one, let's get rid of these instructions. And you see here, I have in the comments some reminders about how basic randomization works. You have the random call, low, high, and your interval or your step. I got rid of the problem text. So let's think about this. What's our function? We have a constant function. Don't be afraid of naming your variables something verbose. For anyone who comes along after you and reads your problem code, it does make it a lot easier to read a problem where variables have meaningful names rather than calling everything A1, A2, or you know, some overly terse variable names. So here our constant function is pi. Again, ending every line in a semicolon, making sure that open quotes have end quotes and open parentheses have end parentheses. These are the kinds of things that get really frustrating when you're just starting out. And let's say I want to randomly set my upper and lower bounds. let's make it a random number between -1 and 4. And again, if I don't specify my interval, it defaults to 1. So the random options that I can get for my lower bound are -1, 0, 1, 2, 3, or 4. End it in a semicolon and do the same thing for my upper bound. All right, so I'm beginning the process of randomizing my problem here. I'm not randomizing my function, but I am randomizing the bounds. Now, how is that going to change my answer? All right, so my answer is no longer pi. My answer is, it's still the constant function, which is still pi, but in case I change it in the future, I'm going to make a reference to the function here in my answer. And it's going to be multiplied by the difference between my upper and lower bound, right? So now I've got my answer object. It's a real number. It's a constant, an integer multiple of pi. And so we're looking pretty good, right? So if we click render, the thing is, this still looks like the same problem. Well, what's the difference? Well, you remember that now I coded my LaTeX for the problem as the integral from 0 to 1. I didn't actually use my parameters in the text of the problem other than to say what the right answer is. So if I look here, what's the correct answer? It happens to be -pi. That's not actually true because I didn't display the correct problem. So let's make sure that we update the problem text as well. So my lower bound is a variable, so it needs to be in square brackets. But because it's also in LaTeX, my lower bound needs to be in curly braces as well, because what if my lower bound is -1? That's 2 characters, and any of you who've done work in LaTeX, you know you've got to make sure that you account for these things. So let's get rid of 0. Let's curly braces for my lower bound so that if it's more than 1 character, they're both put in the right spot. Let's use square braces because we're talking about a variable, and our variable is $lower. Same is true for the upper bound. Let's make sure we use curly braces for the LaTeX. Let's make sure we use square braces for the PGML. And then $upper bound. And then instead of pi here, I could leave it as pi, but I'm also going to use, in case I want to change which constant function I'm using. Again, it's a variable, so square braces. And inside those square braces, I'm going to use my constant function. All right, now when I click render, looking pretty good. I've got bounds that are now different. The bounds are aren't 0 and 1 anymore. But what happened here to my constant function? It's being rendered as 3.14. Well, this is because I've cast my function, even though it's a constant function, I'm casting it as a real number, and WeBWorK turns real numbers into decimals if it's not an integer. So let's change this real and make it a formula instead. If I change this to a formula, now I see, oh, you know what? Formulas can be a lot of things. They don't have to be parsed as decimal valued. And so here we go. I've now got my constant function. All right. So here we go. We've randomized and we've pulled those randomizations into the problem text, and we've also applied those randomizations to the answer object, so that when I look at the correct answers, I see, yeah, this is the correct answer for the randomization that I'm displaying. We can change our randomization and make sure that this is consistent. Show correct answers. This should be, oh yeah, -3 pi. Now the thing is that this isn't exactly what I would want students to see as their correct answer once the answer date is passed. This isn't particularly instructive if a student is unclear about what the answer is or how they should get it. So we can make a few other changes. One is that our answer object is again being cast as a real number, which means at the end of the day, WeBWorK is going to take whatever's inside here, whatever expression I've given, it's going to turn it into a real number, which to WeBWorK is a decimal representation when appropriate. So what happens if we turn this into a formula? Just like we did with the constant function, how is this going to play out? When I render the contents and I look at my correct answers, hey, look at that. I've now got pi times -3. Not exactly the best way of looking at it. You know, like maybe I'd like to clean it up a little bit, but we're pretty far along here. So there's a configuration setting for context that I use almost all the time. This is referenced in the intro markdown file in my GitHub repository that I linked and showed here before we got started. Contexts have these things called flags, which is really just like options usually that you can turn on or off. There are other options in here like the tolerance, where you can set how close you need to be to a approximation of a real answer, a real number answer. But the flag that I'm interested in is reduce constants. When I turn off reduce constants, then that means for my formula here, I don't like really the way that this looks. Pi times -3. I'd rather this be represented as -3 pi. It's a little cleaner. It's how I would actually write it. So what this allows me to do is reduce this formula without turning it into a decimal object. All right, -3 now in front, -3 times pi. Even though in the formula I've got it as, you know, clearly pi times the difference, now it's a little more simplified. If I wanted to take it one step farther, this is really unnecessary, but I get very OCD about these things. I can say the width is actually, I want the width to be, I don't want the parentheses around the -3. I want to compute the -3 and then tack it onto the pi. So, you know, you can do these things in any number of steps. And then instead of multiplying by the difference here, I'm going to multiply by my new parameter, width times constant function. Ooh, where did I mess up? Oh, I got a spare parentheses in there that I forgot to get rid of. When I look at the correct answers now, no parentheses, -3 pi, we're all set. Okay, so this is a way in which we can introduce random parameters into our function. Let's say that I don't actually want this kind of situation to arise. You know, I'm teaching, you know, like I'm just introducing my students to the idea of integration as area, and I haven't really talked so much about what happens when you're reversing the bounds on my integral. So let's say I want to do my upper and lower bounds in this range, but I don't ever want the lower bound to be greater than the upper bound. Here, even they could both be equal and I'd get, you know, an integral of 0. That's correct. But maybe I don't want my students to have to face that situation yet. So I talked about using a do-while loop. Using a do-while loop, you just say you want to do something. I want to do this randomization. The spacing here is just for decoration. It's not like Python where, you know, things will break if you don't space them out, right? So what I've done is enclosed my, let's do this right, enclosed my randomization in a do block. So what's going to happen is that Perl will repeatedly perform this action until those variables satisfy some condition. And the condition that I want to be satisfied is I want the upper bound to be strictly larger than the lower bound. And if that situation is not the case, then Perl will loop through again and pick two new numbers and test them out. And it won't let the problem proceed until I satisfy this condition. So when I click render, I haven't changed the random seed. So theoretically, this should still be the case, but my code now prevents the lower bound from being larger than the upper bound. So when I click render, I get an actual new randomization. And no matter how many randomizations I try now, I will never end up in the situation where the lower bound is larger than the upper bound. All right, so I'm going to open it up to some questions. We've only got about 5 more minutes here, but we've started with the basic framework of a static problem. Just make your answer object, write your problem, and evaluate the student response, to actually trying to introduce some randomization, and then how do we control for that randomization?
Question, Andrew.
Yes.
What's the, I sometimes gotten stuck on this one. What's the point of context? And can you have multiple contexts? How does that fit in?
You can absolutely have multiple contexts. So let's say I wanted to, ask students for an interval, something about intervals and points. I would need 2 separate contexts. I would need a context in which to build the interval answer object, and I would need a separate context to build the point answer object. So here I've only used one context, but if I came down here and I wanted to, I can just start a new context by declaring a new context. So let's say I want points. Okay, so now I can define a new answer. Answer 2 is some point, 1 comma pi. Okay, so yes, nothing has changed. My original answer from being in this context of numeric, and nothing will change answer 2 from being a point in a different context. So yes, absolutely. If you're trying to build a more complicated problem with several parts, and if those parts have answers that are different types of objects, you will need different contexts.
Hi, Andrew. This is Daniel Garvin.
Hey, Daniel.
I have a question. Oh,
sure.
Let me start the video. So, oops. Wrong video. So I've programmed in WeBWorK before, but my issue was that I would have to work locally on my machine, then upload the questions on the server. Then if there was an issue, I could edit on the server, the file, but then I would also have to make those edits locally.
Yes.
So a lot of back and forth.
Yes.
And there's no direct upload as far as I know, like from the command line. Everything is done through the interface. So.
You're talking about putting problems into a WeBWorK 2 instance?
Into my WeBWorK, yeah.
Yeah, just through the file manager is all I can really recommend. Right here, I'm doing editing in the collaborative editor between Readily and the WeBWorK project, so that I have, edit and render right here side by side. But again, I'm still storing these problems locally, and I would have to upload them to a WeBWorK instance as well.
So is this something? I mean, I wish I would have access to something like this editor, where before I upload, I could see.
Sure. If you look on GitHub, the Readily GitHub has this, and there's a Docker file, which is what I'm using. I'm just running this in a Docker container. The instructions are all there. It's pretty straightforward.
So
but if you have questions, feel free to reach out. I'd be happy to.
So you must have Docker. You must use a computer that supports Docker, correct?
Oh no, you could also just run it outside of Docker. I just find it clean and easy to just have it in a Docker container. But by no means do you have to use a Docker container to do it. If you don't, you still have some of the other restrictions of, the usual WeBWorK requires Perl packages, and so you need some way to install Perl packages on your local machine. If you're not running in a Docker container, you have to install those packages yourself. The nice thing about the Docker container is it handles all of that for you.
And by the way, sorry, that's my face. Sorry, I had the wrong camera.
Hey, there you are.
And for the there used to be this answer compare, I remember, and
Yes.
here it's not quite clear how the student's answer is compared to your answer.
Yeah, it happens automatically through the math object. So there are defaults. Now, all of those defaults, as usual, can be completely overridden. It's beyond the scope of what I wanted to get into in the intro here. But yes, it all happens in the PGML right here. Following the answer blank, you just say what the answer is. Now, the answer is a math object, and so it knows how to be compared to the student response. And so that all happens using the defaults.
And will this work if you had several parts like A, B, C?
Yeah. Yep. So I could
answer 2, answer 3, and so on and so forth.
Yeah. Let me see. I didn't get to talk about the pop-up template that I wrote. But you can do a pop-up. Here you see I've got even pop-up, which is a multiple choice option. You can see it follows exactly the same syntax. It just knows how to render itself as an answer option. And there's more than one of them.
And I think I've missed some of maybe at the beginning, but when I was programming on WeBWorK, and I've programmed before.
Sure.
I may have program experience in several programming languages, but at times I would encounter an issue, an error, and then it's just very difficult to figure out what because of
programming in general, but
no, but the documentation for PGML,
sure,
3 programming languages almost into one. So
I would recommend for as far as the current frameworks, math objects and contexts and things are concerned, take a look at this document. I've linked to a lot of the existing WeBWorK documentation on math objects, for instance. So you can see here that the WeBWorK wiki is filled with information about what are math objects, how to use them, how is the context relevant, and there's a good amount of documentation here. Now, as far as documentation for the individual like advanced contexts and things themselves, the documentation on the wiki is broken after the migration to a new server, but you can look up any of these macros on the GitHub site, and they all have documentation at the leading portion of their files.
And one more question. I'm sorry I took so much time from with this. The palette that you have on the side for special or square roots and whatnot.
Oh yes.
That's only available with a certain version of WeBWorK.
2.15 introduced MathQuill, and MathQuill is a supplement. It's an optional supplement. You still have to go into course settings and turn it on, but it does support live rendering. So as not to really need the preview my answers anymore. It automatically turns the student response into its corresponding.
By going to course setting in my own course, I can turn on the quill.
Math quill, if you have 2.15, yes, you may.
Okay.
Yeah.
Thank you so much. And sorry for taking
No,
questions.
it's all good.
I'll just throw in a plug here for the forums as well. If you try to do something authoring wise and it doesn't work, the best thing to do is to post your code and what you are trying to do. There's a few people that are very good at this that can often answer that for you.
Yeah, absolutely. That's, again, I wouldn't be where I'm at if it wasn't for all the help I received. You can, you know, the thing I love about the forums, you can go back and look up, still find old questions I asked back when, back in the day.
Hi, Andrew. Can I ask you something? I had to step out for a minute, but maybe you already answered or mentioned something about this. So I see that you're using, and I guess this is the new direction we're taking within writing the problems in WeBWorK, the PGML. But some of the old codes have begin text and text. So do you recommend to switch? Because what I usually do, I take a code of a problem and it's begin text and text. I'm very aware how that works.
Yes.
PGML came after, so I start to understand. And what I usually do, I use PGML for solutions only and leave the rest as begin.
Yeah, you have to be careful. You know, the old way of doing it, you had to turn on text strings and normal strings. You had to manage whether, you had to kind of manually tell WeBWorK to stop interpreting code.
Yes,
and start looking for LaTeX code. You know, like there were certain things that you had to specify manually that now with PGML, you just don't worry about it. PGML block starts, ends, and then that's it.
Okay, okay, good, thank you.
Yeah.
Just one quick comment. Daniel was asking about the math quill. Daniel, we have 2.15 and it's enabled, so you can configure it from your own account.
Okay, thank you. Thank you.
Thank
Awesome.
you so much,
Yeah.
Drew. So I'm just looking at the time, and so now let us take a lunch break. So we're set to take a lunch break until 2:30, and then after 2:30 we'll reconvene, and Drew is going to talk about how to write solver resistant problems, and that has been a hot topic lately. So we'll see you all again at 2:30.
Awesome.
Same link, same Zoom link.
Same bat channel.
Same bat channel. Thank you, everyone.
Are you sending the food to us, or do we have to go and
I'm
eat
coming
somewhere?
to your house for lunch, Ramon.
Okay. All right.
All right, we'll see you soon.
Bye-bye.
Bye.